Hello, and welcome to this introductory video on the system and the design patterns of Genome Pro, version 2. My name is Guido, and I was MardoQ's partner for this project. There's an apparent need for a tool that biomedical researchers can use with their genome files. Not only do they struggle as they perform the necessary steps to find patterns with their genomic data, using programs as Excel to perform calculations, but none of the current ways that are used to find genome patterns are intuitive, effective, or capable of handling multiple large amount of jobs at once. As biomedical researchers search and discover genes that deal with cancer to prevent further patients from getting ill, the need to do genome differencing as well as pattern matching has become larger. Genome data files need to be cleaned up, and there is a need for a tool that can do that quickly. This is where Genome Pro 2.0 fits, as it is a program designed to solve the current issues that biomedical researchers are facing today. Here's the Gantt chart for our team this semester. We broke down every user story over the course of 7 sprints, in which each user story was done by either me, MardoQ, or us both. For user stories, we implemented a total of 35. Here you can see 5 of the user stories, which are Modify Existing Forgot Password feature, Existing Register page, Existing Login feature, Submission feature, and Changing Results from Email to FTP. I welcome you to pause this video at any time to read the description of these user stories so that you can get a better idea on what each user story is meant to do. Here are the next 5. From top to bottom, these are Modify Existing Task Selecting feature, Existing About page, Existing Profile page, Existing Home page, and allowing PHP PG admin access to admins. The next 4 are shown here. These are Allow user features to administrators, Modify existing tools page, Create file verification program, and Create FTP GUI page. 4 more are shown here, which are Create Ubuntu Server cron jobs, Create validation C program, Modify existing history page, and Integrate genome signatures functionality tool. The next 4 are shown here, which are Redesign Tools page, Create Forgot Password functionality, Resend Last Email function, and Integrate Fast Subsequence tool. There's 5 more to show here, which are Create Graphs, Create Probe C program, Create Unique Sequences C program, Create Repeated Sequences program, and Organize Files by Name. 4 more are shown here, which are Easier Tools page features, Result to Upload Files, Media Queries for Website, and Create Genome Pro promo video. These are the last 4, which are Create Sort tool, Create Maps tool, Extend Extract tool, and continue adding mobile support. Again, due to time constraints, we won't be going over these on detail, but you are more than welcome to stop and play the video to see the descriptions and get a clear idea on what these are all about. The following is a UML diagram of all the use cases that we implemented throughout our user stories. I'd like to point out the most important ones, which are to submit specific jobs, for example, find repeated sequences, find unique sequences, etc. As those are required to create not only the C programs involved with the algorithms for the data processing, but also required the PHP scripts that handle job processing from web tier side, as each job needs a proper entry on the database and a lot of verification needs to be made to prevent any improper argument that might make the programs ultimately fail. This register use case is a great example of how Genome Pro 2.0 is structured. I will use the sequence diagram to explain exactly what I mean. As you can see, there is a clear MVC design pattern with the way the actor is able to register. First, the actor enters his credentials on the register view. Then, the register view sends these credentials to the register controller, which validates the credentials using a validator class. Once those credentials are okay, the register controller checks for a duplicate on the database by notifying the user model of the request. The user model replies, and the register controller asks again the user model to add the user to the database. The user model, being the only one that has control with the database amongst what is shown here, adds the user and lets the controller know if the user has been added. This is when the register controller creates a confirmation email, and the email is sent to the user. When the user clicks to confirm his account, a very similar procedure happens. in which the register controller communicates with the user model and the user model communicates with the database. This communication pattern is common in most of our use cases. This is the login use case sequence diagram. Notice the similarities with the register use case and how communication is purposely limited to increase the reliability and security of the system. The user sends login information to the index controller through the use of the index view, and the user is confirmed by the user model. This is the logout sequence diagram. This example shows what occurs when a model is not really necessary, as logging out does not require any database functions. The submit job sequence diagram, although more complicated, does the same thing as the register sequence diagram in terms of structure. In short, the user creates and submits a job through the tools view, which sends the information to the tools controller where it is validated by, and finally sent to the job model to finish processing the job. A similar thing happens with the upload file sequence. Notice the system helper, which is just a collection of functions that most controllers share that are put in that specific location so that no code repetition is done. Also, notice this sequence diagram has two paths that are both distinct. However, submitting a job and submitting a file are still the same thing because submitting a file is actually pseudo submitting a job, since we have a validator program that validates submitted files. Here's one of the more complicated sequence diagrams, or the profile diagram, which has a total of 3 paths. Notice again the common MVC framework. You are more than welcome to pause the video and read over this diagram carefully. This is the job history sequence diagram, which retrieves a history of all user submitted jobs. Again, a very similar MVC structure, where the controller speaks to the model speaks to the database, and controller speaks with the view. Shown here is the create charts sequence diagram. Uniquely, the page refreshes mid-transaction, as when the user clicks a file, the site needs to be updated to display information gathered about that file. We did not use Ajax, but if used, refreshing the page can be removed. Notice again the use of the system helper controller to do some of the tasks shared by multiple controllers. Also, notice that the file info is retrieved twice, which is another issue that might be prevented with the use of Ajax. The following is a delete file sequence diagram, very simple and structured in the same way as previous sequence diagrams. Last but not least, this is the admin manage sequence diagram, which contains a loop as the admin enters more and more queries. As a final thought, there are more sequence diagrams and information about them on the project documentation, but we did not show all of them due to time constraints and similarities in structure. Here you can see a high-level view of all the controllers, models, and views that we have. As explained with the sequence diagrams, GNOME Pro 2.0 uses an MVC model view controller architectural pattern. It is appropriate for the system and it emphasizes modularity and scalability, thus allowing the separation of data, logic, and user interface. You can see that we split, using the MVC architecture, the system into 3 packages, namely the UI package, the controller package, and the data package. This slide shows the deployment diagram of the whole system. We have 5 tiers, namely client, web, system, logic, and data. We split GNOME Pro 2.0 this way to control which tiers communicate with each other. This promotes modularity and creates a more robust and secure system architecture. For example, because the logic tier only relies on the information given by the system tier, any queries that need to be done are changed only on the system tier. In a sense, the logic tier doesn't need to worry about submitting queries that can be volatile and may result in the failure of those programs altogether, instead relying solely on the information that it expects. Notice that the web tier has no direct communication with the logic tier, but the system tier acts as a middleman between them, in charge of collecting what the web tier has given to it and converting it into queuing new jobs to the logic tier. The great benefit of this all is that if any of these tiers need to be changed, a simple swap, as long as the input and output of that tier remains, will not break any other tiers, which is helpful if, for example, one day the system tier queue system needs to be changed from cron queuing to parallel computing. When designing the database schema, we thought of what biomedical researchers will be mostly interested in. It was evident that the tools of GNOME Pro are the most important, and that because the number of tools increased as time goes by, there was a need to build a database around the tools. As of now, there are 6 tables. Using joins, multiple information can be obtained about each user, including their jobs, what tool that job uses, what files are involved with that job, and even what kind of type the file is. We made sure the database for GNOME Pro 2.0 uses a good database system for handling large amounts of data if need be, and also, with requests from the product manager, decided to ultimately use Postgres. We also made sure that the database model was in third normal form, and that primary keys were stated in any one-to-many relation. For security, we thought to consider anything that might affect our website. One of the biggest and simplest attacks to websites, specifically those that use PHP to connect to some sort of database, is SQL injection. To combat this and prevent sensitive data to be accessed by malicious users, we used prepare statements to verify what would normally be seen as queries as regular text, in which we use the help of a database library that handles row retrieval and execution with the use of protected variables. We also log the users out after a long period of inactivity to the login page. This helps users who may have left themselves logged in protected to attacks of malicious users who wish to download any sensitive DNA data. Pages can also only be accessed when you're logged in, so that no guest user has access to any of GNOME Pro's tools. The FTP verification was very important to us, so we made, using Apache's authentication system, a way to password protect the user's FTP files. In any case that a malicious user were to access the FTP page's links without going first through the site, the malicious user will still have to log in with the FTP page's username and password, which are the same as the ones used to register onto GNOME Pro. Shown on the screen is a more detailed version of the connections between our models and our controllers. Notice that the user model is used by a lot of controllers, including the register, profile, and logout controller. The user model contains a lot of useful functions, including login, upload avatar to database, confirm registration, get profile, etc. All of these functions use the database in some sort, which is why this logic is placed onto the model instead of its respective controller. This slide shows another section of our model controller diagram, which explains the connections between the tools page and the job and file model. Notice that the tools and files model don't depend on each other, but the job controller depends on both, since a job is composed of both a tool and one or more files. There are very helpful functions inside both of these models that make submitting a job really easy, and any of these libraries can be changed if one day submitting a job does things in a different way. Shown here is the view controller diagram, which shows which controller communicates with each view. Notice that we use the same naming convention for both controllers and views, although in the project they're in different directories. Although the About and History page don't really need anything from controllers, we gave them controllers in case one day these pages require something to retrieve or to send. The System Helper and Template controllers are shown here, with the connections and influence that it has on all other controllers. As previously said, these two are special since they are used by every other page, since the System Helper contains functions that would be redundant to have on every page, and the template contains functions that make way for controllers to communicate with views. Notice the Validator controller, which is only used by some pages, that contains some helpful functions as well. These functions were not placed on the System Helper due to their similar nature with each other, yet differences with everything else on the System Helper. In the next couple of slides, I will show 3 sunny and 3 rainy test cases performed on user stories for GNOME Pro 2. We have around 15 test cases, but we decided to only show 6 to explain how we tackled testing. You can view the other 9 test cases at the product documentation. Shown here is the sunny test case for uploading a file to GNOME Pro. Notice the description, which says the valid data types that should go through the site. For conditions, it's important that the user be logged in and on the tools page. When the user clicks the Choose File button, a file is selected, Upload is clicked, and a success message box should appear. We did this test case using Selenium and checked manually to see if the file was inside the server. The rainy version of the previous test case is shown here. This time, the user is submitting an invalid file, and the server should not accept it. As you can see, the test case passed, the correct error message was displayed, and no file was saved onto the server. The following is a sunny test case for registering at GNOME Pro. Notice the preconditions, which assume the user knows the constraints of the username and password. Errors are displayed whenever something they've typed is incorrect. Once they've submitted all the information, when clicking Submit, a verification message should appear. This test passed and the user row is added to the database, which was checked manually. This test case runs through Selenium automatically just like the previous test case. The rainy day of the previous test case assumes the user does not submit correct information. In this test case, the user submitted too short of a username, and as expected, an error message is displayed with the constraints of the system. No new row was added to the database, which was checked manually. For the contact page, we had a test case to see if the contact emails were being sent through the server. A precondition was for the user to be on the contact page and not logged in, although logged in could work just as fine. In this test case, a dummy email was sent and a success message showed, making this test case a success. Similar to the other test cases, Selenium automated this one, and a manual check of Gnome's email address was done to see if the email was actually sent. Here's the rainy day equivalent of the contact page use case. Similar structure, but the user has entered an invalid email. The right message was received and no email was sent. This test case also passed successfully. I'd like to end this video by showing you two scripts for our test cases. Although I won't go into detail, you can stop the video at any time to look at these if you'd like. We thank you for watching and can't wait to see you evolve Gnome Pro today.